Now the next question is from again 2024 itself. It is about the zero order reaction. What are the peculiarities of a zero order reaction? To determine what are the peculiarities of a zero order reaction, let us write the general equation for the rate of a reaction. We know rate is proportional to concentration of the reactants, and of course to the power of n, depending where n is the order of the reaction. So, and rate will be equal to K into concentration of reactant. I am putting only R to the power of n. Now, for a zero order reaction, this will be equal to K into concentration of A to the power of 0. So, something to the power of 0 will be equal to 1. So, rate will be equal to K. So, that is 1. So, rate is equal to K. So, it is independent of reactant concentration. Check the option 1. The rate of the reaction is independent of a reactant concentration. So, that is correct only. Now, second one, the rate constant is independent of temperature. No, it will not be. Because why? The rate constant K is of course given by the Arrhenius equation A into e to the power of minus Ea by RT. Whether it is zero order, first order, of any order, rate constant will always be a function of the temperature. So rate constant is independent of temperature. That is a wrong statement. Now the third one, rate of the reaction is independent of reactant concentration. So rate constant. So rate constant is independent of the rate constant because rate is equal to K into concentration of the reactant to the power of 0. And if you are making any change in the reaction, in the concentration, immediately the rate will be changed, keeping the K always a constant at a particular temperature. So K will be constant at particular temperature, meaning to say K varies only with temperature. So rate constant is independent of the reaction. That is also a correct statement. Now the last one is thermal decomposition of HI on gold surface is a zero order reaction. Of course, that is a zero order reaction. So once you that reaction goes like this: 2HI in the gaseous phase, it will be reacting on the gold surface to giving you H2 plus I2, very famous reaction. So it is a heterogeneous catalysis type of reaction. So if you take the gold surface, there will be active sites like this, and on all the active sites, this HI molecule can come and adsorbed, and the reaction is from the adsorbed HI molecule. So what is happening is, if there all the vacancies are filled with HI, the reaction occurs from the surface and it appears that this is a zero order reaction. So the thermal decomposition of HI on gold surface is a zero order reaction. The HI molecule, the adsorbed HI molecule is reacting in this case. Adsorbed HI. So in the gaseous phase, it appears to be a constant. So the statement D is also the right one. So since you check the options, you can see the option number 3. That is the right option.